and welcome to your first lesson of your geometry course. So starting out with 1.01, this is defining foundational terms of geometry. What is geometry? We use geometric terms, everyday language, often without thinking about it. For example, anytime you say walk this line or watch out this road quickly angles to the left, you're using geometric terms to make sense of the environment around you. Just a couple things to point out. You do have to score an 80% or higher to move on within the unit, and you can view the progress bar and score down here. So let's start with a skill review. Skills needed for this lesson: being able to identify figures as two-dimensional or three-dimensional, classifying triangles by their angles and sides, and then naming angles. So skill review 1. We have this shape here that is a trapezoid. Next up we have a pyramid, a cylinder, and a pentagon. So of those shapes, which figures are two-dimensional? That would be the trapezoid and the pentagon. Skill review 2, we have this triangle GHI. We're going to classify it by its angles and its side lengths. First and foremost, by angles, each of these three angles, so angle G, angle I, and angle H, are all acute. And then by sides, we have 8, 8, and 6, two of which are the same. So two sides that are the same is isosceles. So we have an isosceles and an acute triangle. And then skill review 3. What is another way to name angle 3? So we have this angle here. We can either name it BVC or CVB. The turning point of the angle has to be the middle letter. And so BVC is the correct one there. Next, we're going to move on to words to know. Definitely still go through these. I'm not going to go too far in depth with each of these, but an angle is made up of two rays that share a common endpoint. That common endpoint is the vertex. And then the notation to name an angle is 3 letters, with that vertex being the middle letter. An intersection of two sets X and Y is the set containing all the elements of X that also belong to Y. And the symbol for intersection looks like an upside down, or not an upside, a lowercase n. A line is an undefined term because it's an abstract idea rather than concrete. It is defined as a line of points that extends indefinitely or infinitely in two directions. It has one dimension length. We label it as line AB, or notation is a line with 2 arrows above it. Plane, another undefined term. This is actually two-dimensional. It can be identified by determining 3 non-collinear points. So we could call this plane ABC. A point, another undefined term. A point in geometry is a location. It has no size, no width, no length, and no depth. A point is labeled with a dot and a capital letter, so this would be point A. A postulate is a simple and useful statement in geometry that is accepted by the mathematical community as true without proof. A ray is a part of a line that has a fixed starting point and continues toward infinity in one direction. And we would name this one ray A, B. You would start with the endpoint, and then the second letter is the letter that it extends through. A segment is a piece of a line with 2 endpoints. It has a length that can be measured, and we would call this AB with the little segment bar, so no arrows on a segment. A theorem is a statement that can be demonstrated to be true by using definitions, postulates, properties in a previously proven theorem. Theta is a Greek letter used in math to stand in for an unknown angle. And then lastly, we have union is the union of two sets contains all the elements that are in set A or in set B or possibly both. The symbol for union looks like a U. Moving on to 3 dimensions. So again, we have a point that is 0 dimensions, a line or ray or segment has 1 dimension. 2 dimensions, we have a plane. And then all of our, obviously, 3-dimensional shapes have 3 dimensions. They have a length, width, and height. And then we talk about collinear and coplanar. Collinear has the word line in it, and those are points that lie on the same line. Coplanar has part of plane in it, and so those would be points that lie on the same plane. So looking at these examples, which geometric term best describes the location of San Diego? And that would be a point. Which geometric term best describes a straight road? This could be a segment. Which geometric term best describes a soccer field? And that would be a plane. Define segment DE. Since the notation is 2 uppercase letters of the segment above, this refers to a line segment that starts at point D and ends at point E. Define F. A single uppercase letter refers to a point, so this would be point F. Define this here, so DF with the line and 2 arrows indicates that it is a line, and it's going to extend infinitely in both directions past the points D and F. And then define EF. It is 2 uppercase letters with a segment above that refers to a line segment that starts at points E and ends at points F. Here we have a 3-dimensional figure that is defined by 8 points. Identify 3 of the points. How many dimensions do each of the points have? And we can kind of skip that one because there's another example in the guided example. And then other names for plane J. This could be plane D, G, K. It has to be 3 points that lie on the plane but are non-collinear, so they cannot be on the same line. So A, C, B would not work. All right, guided example 1. Define B, D. That has 1 arrow, so that is a ray that starts at point B and extends through point D. Define AB. That is a segment. There are no arrows, so it contains the endpoints A and B. AB with 1 arrow, again, is a ray that starts at point A and extends through point B. And then AD has 2 arrows, and that makes that a line. In guided example 2, we have what we call a triangular prism. Notice that there are rectangles, but a rectangular prism has all rectangles. A triangular prism has triangles. Name a point that is coplanar with points F, E, and A. So this shaded rectangle on the bottom, F, E, and A are all on the same plane with point B. How many segments define a triangular prism? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many planes define a triangular prism? We've got this triangle on the end, this triangle on the end, so there's 2, and then 3 rectangles. So that makes 5 planes. And then name the shaded plane. So we have the points F, E, B, A. We only need 3 of them. F, B, E, A. So plane A, B, E. A, B, E. In guided example 3, we've got line L lies in, here's line L. It's not completely in either of these planes. It actually just passes through plane V and plane W, so that is neither. R and Q, so points R and Q are both on line L, making them collinear. And then point blank does not lie on plane V or plane W. The only one that's off both is S. So that would be point S. And then points blank are blank because they lie in plane W. Okay, so if they're both on plane W, that makes them coplanar. So let's look at what points are coplanar on plane W. So we have Q, T, O, and P. P, O, T, and Q. Next, we're moving on to angles. Again, an angle is formed when two rays share a common endpoint. That common endpoint is called the vertex. So we have rays BA and BC. They meet at vertex B. Angles can be named in multiple ways, so either a number, so angle 1, the vertex, if it is the vertex or the only angle, since this is the only angle we are referring to, we can say that this is angle B, or 3 letters. We can say A, B, C, or C, B, A. Here we have 2 angles that share the same vertex, so we can either use a number or the 3 letters, so A, C, D, B, C, D, or angles 1 and 2. For this angle here, it's 45 degrees, so that's not the name of the angle, but we can either say angle CAB or BAC. BAC. The size of an angle is measured in degrees. The measure of angle ABC can be written as lowercase m and then the angle symbol ABC. We can also use theta to signify an unknown angle measure. Classifying angles by their measure, less than 90 is acute, equal to 90 degrees is a right angle denoted by the box, greater than 90 is obtuse, and then an angle whose measure is exactly 180 is called a straight angle. Then we have adjacent and vertical. Adjacent means next to, so this angle here and this angle here are next to each other, so they are adjacent. And then 2 angles directly across from each other are vertical. One thing to note with vertical angles, they will always have the same measure. Complementary angles, if 2 angles are complementary, if the sum of their measures is 90. So if A plus B is equal to 90, they are considered to be complementary. They do not have to be adjacent to be complementary, but if they add up to 90, they are complementary. Supplementary angles add up to 180, and then a linear pair form a straight line. So PSQ and QSR are also supplementary, and they share a common side, form a line, linear pair. There are a couple examples. I'm going to kind of skip over those. If you need to go back to those, feel free. So guided example 1, we're looking for a linear pair here. So let's look at, if we have AXB, and BXC, that together form a linear pair. Blank are vertical angles, so let's look at our options. We have EXD and YXC. So EXD is this angle here, and YXC is over here, so those are not vertical. Next up, our option is YXC and AXE. So YXC and AXE. So this angle here and this angle here, those are vertical angles. Measure of angle BXY plus the measure of angle YXC. BXY, YXC, also known as angles M and N. Together, they would form 90 degrees. They are complementary angles, so their measures add up to 90, and those are complementary. Guided example 2, we have APD, so angle M, and DPB, so angle N. The measures of those, that forms a linear pair, so they add up to 180, and they are a linear pair. Next we have APD and CPB. So APD, so angle M, and CPB. And these are across from each other. They are vertical angles, so their measures are equal. Next we have angle EDP and CPB. EDP, so this angle here, and CPB, this angle here. They are not on, they're not any type of angle relationship, so they don't have a relationship. All right, and then guided example 3. So if the measure of angle INJ, so this piece here, is 63 degrees, MNL, these two are vertical angles, so they are the same. JNK is this smaller portion of the box, so 90 minus 63 gives us 27. And then JNL, so if we know this is 90, this is 27, 27 plus 90 is 117. And then we move on to theorems and postulates. There is not any activity to do on this page, but we do have all of the basic postulates. So postulate, again, is a basic rule of geometry. Postulates are assumed to be true rather than proven. So postulate 1, if there are 2 points, then there is exactly one line that goes through the 2 points. Postulate 2, if there are 3 non-collinear points, then there is exactly one plane containing those 3 points. Postulate number 3, if a line and plane share 2 points, then the entire line lies within the plane. If 2 lines intersect, then they intersect at a point. If 2 planes intersect, then they intersect at a line. So a theorem is a mathematical statement that can and must be proven to be true by using definitions, postulates, properties, and previously proven theorems. If then statements, theorems, and postulates are often written as conditional statements. So if this happens, then that will happen. And then the last lesson portion of this lesson, we have intersections and unions. So segments, rays, lines, and planes are made up of sets of points. A line is the set of all points that extend infinitely into directions. A segment is a set of all the points that start at one endpoint and go to another endpoint. And then a ray is a set of all points that start at one endpoint and extend in one direction. The intersection of 2 figures is the set of points that belong in both. A union merges the points from both figures. So in this first example, find the intersection of line M and line L. Where do they intersect? They intersect at point A. So that would be the intersection. Example 2, this is asking you to find the intersection of segment UM and LX. So UM and LX intersect at point L. And then it goes on to show you a few others. So for guided example 1, find the intersection of segment KF and plane J. So we have plane J and segment KF, and they intersect at point K. Find the intersection of point E and plane J. Again, this is an intersection, so remember the upside down U, or looks like an N, is intersection. And the intersection of point E and plane J, since E is not on plane J, they have nothing in common. For this one, find the intersection of AB, segment AB and CD. So A, B, and C, D intersect at point C. And then find the union of line H and plane J. So line H is this here, and plane J. So because everything on line H is in plane J, we have to include all of plane J, and it's the union. So it's not the set that contains both, it's the set that contains all of them. So this would be the union and plane J. Then we have a couple review questions to look at. So review question 1, A blank is the figure formed by two rays meeting at a common endpoint. Remember, the common endpoint itself is called the vertex, but the two rays that come together form an angle. A blank starts at one point and ends at another point. That would be a segment. Which angle is the marked right angle? So I have angle I, N, K, or K, N, I. I, N, K. And then last question, find line AC, the intersection with ray XB. So AC and ray XB intersect at point X. And that is it. We can go on to our summary, and that just kind of goes through the main concepts of that lesson.